There we go.
Oh, yeah. That looks way better.
Yeah.
Cool.
Yeah, feel free to.
All right. Am I live to go, my friend? I'm good to go. All right. Hi, friends. So I'm going to try a few things here. I'm expecting something to go wrong. You know how it goes, right? Yeah, so many friendly faces in the room. I'm so glad to be here at Rejects in 2024. I think there's a camera somewhere here for all of the folks who watch the recording. My name's Leigh. If I haven't met you before, I'd love to meet you. Last name Capili. I used to work on a bunch of Kubernetes stuff and also continuous delivery with a project called Flux, which does continuous delivery with GitOps on Kubernetes. And I don't know how this happened, but now I work on something completely unrelated at a company, a startup, with 20 other brilliant people. The startup is called Flux with an O. Why did I do that? Yeah, we work on software environments and that kind of thing. The reason that I wanted to work with the folks at Flux is there were some things in this tech stack that were just really appealing to me as an engineer. And I think you can imagine, working in advocacy at VMware, it was kind of maybe harder for me to work on the product because maybe some of the code base is even a little bit private. And I'm like, wow, when I get on my next team, I want to make sure I can do what I did with Flux, which is actually advocate for the thing that I'm engineering on. And we write stuff in Rust, and we build a usability layer on top of Nix. So what is Nix about? Nix is about this problem in a lot of ways. Nix is a lot of things. It's a Linux distribution. It is an academic paper. It's a functional programming language. It is a Linux distribution, but it's also a Darwin macOS distribution. How does that happen? You can do Nix stuff on BSD or anything that's POSIX compliant. I mentioned that it's for functional programming nerds, and you can also use it to manage your home directory. So Nix is this thing that lets you do lots of stuff, and you can hold it whatever way you want. And my clicker is working. Software, when we want to build it, we build it on top of lots of stuff, right? So we have tools, libraries, frameworks, and configuration. Slides brought to you by the amazing Ross Turk, who's sitting up there in the top of the bleachers. And we have fun little shapes and colors here. I love our brand. When you have multiple projects, right? So you've got the tools, libraries, frameworks, config. All of your projects have different mixtures of that kind of stuff. And this is maybe nothing that we really think about too much, but I think even if you're a beginner engineer, right, you start to intuitively build up this knowledge of separating these different categories of code and configuration and the things that you are depending on. And sharing these environments is really a pain in the butt, right? I mean, this problem of trying to just have a little bit of playtime building something fun with your friend, which is pretty much the best case scenario for software development. I think a lot of times we find ourselves as software engineers in building something that we don't want to build because we need to make money. But in this scenario, we just are trying to have a good time, and making the squares and circles match up so that we can build our software together is already a hard problem. And then recreating the past is even harder, right? Because we do this thing with the system package manager, where we put all of our configuration and our code and our libraries in the file system standard that has become popular on Linuxy, Unixy types of systems, right? We're gonna put binaries over here. We're gonna then have the Unix system resources, which everyone just says it's user now, so there's the user bin. And then we're gonna include some stuff and put some libraries in a place, and we're gonna then put these folders into a path lookup inside of an environment variable that then a bunch of programming languages are going to write things to then look inside of the path, and it's going to be colon separated, and we're going to traverse the directories, and we're going to look for the thing that wins, and this is how stuff works now. So I mentioned Nix. Nix has a different philosophy about how to package all of the squares and circles. So with Nix, when we want to put source code into a place, we hash it, and then we get that special hash, and we put it into the file path. And that source code has a unique path in the Nix store. And then we're going to take the same thing, configuration, and we're going to take libraries, and then we are going to separate them into individual pieces. And then all of the things that you need to then run a library, they don't actually fit into this single path. They end up being built in a way where the library, if it also depends on other libraries and other configuration, it is built. We do a bunch of replacery and binary magic to take what is normal, right? We load libraries typically from this library path. We teach the binaries that we build inside of a Nix store instead to look for the things that they need exactly, the things that they were built against, that they depend on. And so when you have a Nix store, this thing can actually then be pointing to this thing, and this thing can be pointing to 5 other things. And you get a fully capable dependency graph right on the file system, because the binaries, they don't know how to behave any different. They were built specifically that way. And so Nix lets you weave your code together dynamically so that you can have all of these things in the Nix store, and then the code gets exactly the bits that they need. And that is magic. It's more than just a package manager. Nix is twice as old as Kubernetes, with a contributor base of about 7,500 people. There is the largest package ecosystem in the world. I'll just show you now, because we really don't have that much time to talk about the basics anymore. I'm going to just spend most of the time fumbling around on the keyboard. Are we cool with that? Can we do some demos? I'm good with it. All right. So I'm going to put this out of the way, and we're going to try. We'll just put it on the floor. We don't need that right now. Okay. So we'll swipe over one of these directions. How many times am I going to fight with my window manager today? That is work stuff. Here we go. Oh, the aspect ratio of everything has changed. Cool. So this is our website. You can go check us out if we want. We make a usable layer on top of Nix, which I'll do plenty of demos of today. But this is Nix packages. This is the most bonkers Git repository I've ever looked at. It's NixOS/Nix packages. Hopefully it's pretty legible for people. That's a graph of contributions since January 1st, 2004. And it is 2024, and there are people making lots of commits every week. And if you go over to the code, let's just ignore the fact that there's uncountable numbers of issues that are open and pull requests. That's 706,000 commits. This is where the 120,000 packages come from. And thank you to all of the Nix contributors who have done the magic of packaging everything. I'm going to jump into why we care. So the point of today's presentation is to contextualize why a cloud-native person with the luxury of the container image and the container runtime would care about packaging software in a way where your software only knows how to find what it's supposed to get to. Because if we can build our software in a way where we got it to work and we got it to pass tests, and we can wrap it up into a little box and push it around into a registry, then why would I care, right? I can use some very imperative tools, and as long as I can get to a working artifact, then I'm just going to store those bits forever, and we'll be able to run it on some functions as a service thing, in some Kubernetes cluster, and maybe even in Docker desktop, right? So all of my needs are met. Why would I need to package software in this way? Why do I need to change my habits? Well, for one, I happen to be using a MacBook. And MacBooks have really cool kernels that do have isolation features. The Darwin kernel in particular is the same kernel that's used on an iPhone. I don't have one of those, but a lot of people do. And the Darwin kernel has isolation features, but it cannot currently run OCI containers in the way that you want to. There's actually a Darwin containers project, really cool. I think that we could maybe use Darwin containers in the future to do some Floxy and Nixy things. But it's not really something that people do. So in order to use all of the software that we want to package, as cloud native people, we end up like using things like Docker or Podman or nerdctl or something, and we get access to a daemon that is actually running a Linux computer, right? Here's the thing about almost all of the software that's packaged in modern day Nix packages. Most of those 120,000 packages are actually cross-built on a public build farm and then cached in a binary cache that's hosted on like a 1.5 petabyte S3 instance. All of that software is available natively for my Mac, which I like, because then maybe I don't have to run a virtual machine as often. So I'm just going to show you a Flux environment. Can we read that? How much bigger? Like, how's this, Orlin? That's better? Yeah. Thank you. Good advice on the aspect ratio change there. So I have a Flux environment. This is basically just making it easy to list what software I'm using from the Nix packages ecosystem. So again, Flux is this open source project that we're building to just make it easy for me to demo how to use Nix. But I'll show you some pieces here. So I am listing things in my home directory. These are the packages that I want to have installed on my system right now for this use case. And you'll see, I've got like ZSH pinned here, as well as like my favorite text editor for terminal stuff, and a version of Go and curl and core utils, and my favorite way to cat out stuff. And this got here because you can like, I don't know, say we want to do like some more like infrastructure as code stuff generally. I don't normally install this to my home environment, but you could like do this. And we just install our packages to, I guess I have to pull a new version of Terraform right now. And I don't know how long I don't really know how long I want to wait around for this, because we're already at like 16 minutes into the time block. But what I'm doing right now is I'm installing to my computer the way that you would normally use a package manager. The way that we sort of want to think about changing our workflow though is, like, I use my computer as a workbench for building lots of different kinds of software. And eventually I get to a place where I want to start a project. And I want to then install some dependencies to that project. I'm just going to open another terminal here while this is doing that thing. So say that I also go into some project directory. I wonder how many times I'm going to need to increase that. Let's actually go, and I'm just going to increase the font size here really quick. Oh, wow, I'm already at 17. Let's try 24. Maybe that's better. Yeah, OK, we can read that, right? OK, perfect. So let's make a directory. We'll call it just like regex2. And by the way, I guess Terraform is actually failing to build right now. That's incredibly surprising to me. Cool. Sorry? Yeah, thank you. Let's just OK, cool. So I'm making a folder here. What if I like initialize a project, right? And then I can like install Go, and then maybe like a text editor, and then also like something to do some Kubernetes stuff, and then maybe I also want kubectl. Let's go ahead and just like install a couple packages here. And what we're doing here is I initialized a project. So instead of thinking about installing stuff to my computer, I do what normal software engineers do, but instead of with like packages inside of Go, I'm installing system stuff to a folder. And then if I go into that folder, you'll see a directory structure here I have a manifest and I have a lock file. Oh, lock file, right? Because it's like you installed things, and those things, they have versions, and I actually probably would never want these versions to change when I want to share the thing with my friend. So it's good, to have a machine-readable lock file. Right? You can see that it's good for a bunch of different systems here, and then this derivation, which is the fancy Nix word for the thing that we built. At one time, it has either an input or a content addressable hash for this particular version of the Go programming language. This is how it was resolved and where I got it from and what time it was resolved and what thing did I actually ask for a pinned version, or is it just pinned out of convenience, and that sort of thing. And ultimately, what we want is to then look at, like, say, the runtime directory and everything in here, my configuration in Etsy, my and my binaries, they all point, they're symlinked to things in my Nix store. So I actually started a lot of different projects inside of this Mac. And if I just list my Nix store, you'll see that there's lots of different kinds of software that ends up in here. Who knows why I have docbook XML, but something I was working on needed that dependency at this specific hash in this version. You'll notice that everything here is 55 years old. That's because every package that was ever cached inside of the Hydra build system, it's a bunch of shared infrastructure for the public project, rebuilds the universe iteratively, and when we build those packages, we would like to make sure that the package gets all of its inputs from the network in a very isolated way, and that all of the builds actually happen in a mountain network namespace that has internet access disabled. And then we also pin the system clock so that the build, the output of the build is bit for bit reproducible. That means that when we decide that we want to build Go from Nix packages, we can trust that the recipe will produce the same bits every time, which means that we can put it into a binary cache. It's starting to sound a lot like with the either hashing the inputs or hashing the content, and then caching this individual node of the dependency graph. It sounds a lot like an OCI registry. Now, here's something that looks a little bit less like an OCI registry. I've maybe worked on, I don't know, let's just look at my home env directory. This is usually where a junk ends up for me. There's 44 directories in there. So I've worked on 44 different kinds of things, and that's because I live in the fresh hell that is developer advocacy. I guess if I ask Flox envs, this outputs every environment on my system. So I guess I could count those, and it's roughly 72 or so. Only 72 different types of things. But if I list the Nix store and I count what's in there, it happens to be 51,000 dependencies. Well, you're not going to end up with 51,000 container layers when you work on 74 Docker images, right? None of them will relate to each other because every time you change a file, every layer afterwards becomes invalidated, and that's because container layers are based off of file systems, which are trees. And anytime you invalidate a piece of a tree, everything afterwards that is overlaying on top of it depends on that particular layer. And so the difference here with the Nix store is we can be much, much more granular. Many of these derivations inside of the Nix store, out of these 51,000 things, are actually even just single files. Sometimes they're just shell scripts. And so they don't depend necessarily, or they don't invalidate anything that they're linked with. Right? If I want setup.sh for a particular part of a dependency tree, I can get the 5 things that are related to that, and I can use them across a bunch of different things. And it gives me a much greater resolution dependency caching. So that's why you would maybe want to start rethinking about reshaping the container image. Now, I have a couple of other things that might be interesting here for you, so I'm going to start switching machines, right? Let's go ahead and just go back to that regex2 environment. I'm going to Colima SSH here. Lima is a virtual machine on Mac project. Thank you, Akihiro Suda-san, prolific contributor in the containerd space. Colima does this thing where it read-write mounts your user directory from your Mac. And so I happen to now be on a Linux system still with that Phlox environment. What'll be really fun is that you can just activate it. Right? So I've just gone from Mac to Linux, and using the power of the Nix daemon, resolving against Nix packages and stuff, I have the specific version of Go, the co command line tool, kubectl, and micro, all at those versions using the lox file resolved, but now instead of getting Darwin binaries, using the same hash, the same package name, I am working on a Linux virtual machine. You say, well, Leigh, if you're working on a Linux virtual machine, why wouldn't you just use a container? This is where maybe something, I don't know, this might be kind of silly. Can I just it would be this one. And then maybe you could do this. And then I think it says I'm connected to an external display. And I wonder if the AV crew is maybe despising me right now. But, so then maybe I'll try to find the camera. And then I will just be I'm not going to bother with pulling up the same exact environment, but this is Nix on Droid. It is a single user mode Nix installation running inside of an APK-driven Android app. Android is a Linux kernel running containers essentially for every single one of the apps. You are completely unprivileged. The user ID is 10,500. And I'm using Phlox and a single user mode Nix install, and you can access all of the same exact software. So Terraform, whatever. I'm going to just pop back up here and go into the regex1 environment. This has Go, Grafana, Prometheus node exporter. In order for me to actually use these things, I need to Phlox activate. I'm going to use this short flag. Sorry. Thank you. I was like, it's not presenting. I'm back on the Mac. Cool, that should probably, there we go, yeah. And there's a bunch of services here. So if I go over here, then I guess node exporter is running, and then Prometheus and Grafana were unhappy for some reason, right? But you can actually use the Prometheus binary natively here. I guess it probably is complaining that I need to touch a Prometheus YAML, and then it'll probably start. Yeah, so we're running Prometheus here. I'm just gonna exit that. The last thing I want to show you in the remaining 3 minutes here is I'm gonna pop open into a proof of concept environment. Where let's actually just look at the code. We're going to need to increase the font size significantly, but not that much. Let's get a bunch of these notifications out of the way. And in here, I have this thing called Nix Host Manager. It is a daemon set that runs on every node of your Kubernetes cluster. It runs this minimal, oh gosh, what did I just do? It runs a minimal container image that has Nix inside of it. We're just getting a couple things and then holding the container open so you can shell in and run Nix commands. And then we're doing a volume mount from host data /Nix directly from the host. And then the build runner in a different namespace uses this privileged container. We could probably use a capabilities list here. And then we mount some folders from some volumes at the bottom here, create an overlay empty vol as well as a Nix in container mount. We're going to basically make an overlay data dir here, and then use a privileged mount manager container to get host data Nix, and then overlay FS into the Nix in container mount. So that's what this little script does right here. And then in the user build container, you can then cache hit on the host Nix store, which is read-only, but then overlaid inside of the pod so that you have a little layer on top. And that will let you start to get the packages from whatever you want. You could then install Flocks on there and then run Prometheus or your Go application or some vector database or whatever you like. There are two more things in the Kubernetes infrastructure world that I also want to point you to. Lin Feng is a contributor who has written this ORAN-C. It's called OCI Registry as Nix Cache. So I mentioned earlier that we had that like 1.5 petabyte S3. Thank you to Amazon for the credits for hosting that for the community. You get to say thank you, Amazon. All right, how many times do you get to say that? OCI as Registry as Nix Cache would allow us to basically use an OCI repository as a Nix store that is addressable by a daemon. And that's pretty cool because then now we have a place in our Kubernetes infrastructure to push binary builds to. If you want to build something with Nix or you want to just move some blobs around so that you can cross an air gap or that kind of thing, OCI Registry is perfect for that with like lots of authorization and signature use cases. Thank you, Engin. And then similarly, now that there's a Nix cache that's co-located with the network, your daemon set can just go and super efficiently substitute all of the stuff from the Nix store directly into the hosts. But here we're sort of really abusing the node abstraction, and we're using privilege to then create a bunch of dynamic overlay mounts. There's also like a variation of this. You can see there's this Kate's overlay directory where it's even more complicated. There's a specific feature in Nix that we can talk about later that makes it so that the read-only overlay store underneath all of the containers can be dynamically mutated even as like long builds are running on top of them. And that's because there's a SQLite database that gets overwritten on the file system that you have to manage. But beyond this, it's like if we ran OCI registries as a Nix cache, like with this project, which you can get started with. It's fully Nixified, and they also have binary builds and even like a public instance. PDT Partners, another great contributor in the Nix space, has written this thing called Nix Snapshotter. And this is a direct integration with Containerd's Snapshotter plugins ecosystem. It is called a remote snapshotter. It's similar in a way to what like Steve-O and Akihiro and some of the folks from Google wrote with E*GZ, as well as Soki Snapshotter, the ability to stream container images. But instead of streaming container images from S3 or Google Cloud buckets or something like that, what we do is we construct layers directly from a Nix store, such as an OCI registry or a local directory on a node file system that's managed by Nix Host Manager. And then instead of constructing the container with an overlay mount file system, you could also, for all of the store paths, because they never conflict, they will never step on top of each other because of the hashing. They all are supposed to live flat in the Nix store, just like images, or just like layers. Then we can actually just use bind mounts. And I don't know if you know this, but there is a limit to the number of container, the number of layers that you can use in a container, right? Like if I Kalima SSH, and then I like say go into, I don't know, a Go environment or something like that, and I Flocks containerize this environment. This is gonna take a sec, and then how can we quicken this up? I can also Docker history the GHCR io/flocks/flocks image. So this is a container that is built with Nix. You'll notice that there are a lot of layers here. There's about 100. I know that because we are stopping 20 layers short or so of the 128 layer layer limit. And then the very last layer, we just shove a bunch of different Nix store paths But the goal here was to actually give every single one of the Nix store paths a unique layer, right? And that's because you cannot create an overlay 2 mount with more than 127 args or so. And that's where the layer limit comes from. But since the Nix store paths are guaranteed to not conflict with each other, if we could either update the OCI standard or use some non-standard extensions with containerd through something like Nix snapshotter, then instead of constructing an overlay 2 file system to create the container, we can just bind mount a bunch of stuff in. And then you can actually then use another 128 layers to construct an overlay file system to live next to your Nix store. And that, it could be, it's already something that functions. I mean, if you use Nix snapshotter, you can create OCI manifests that it will understand, and you can use Nix natively. But I see a future here where we could build some incredibly comprehensive standards that make the build graph so much cleaner, so much more granular, which such a greater cache hit ratio. Like the implications on the infrastructure are massive. Now, in order for that future to exist, we have to make Nix a little bit more usable than, here's our flake for actually building flocks. Lovely functional programming stuff. Don't you want to learn how to do this? It's great. The stack traces are even better. But we can make Nix as usable as brew, as usable as Git. And that is the function of our open source project. It's what we're working on. I'm happy to chat more into it. There's so many ways that Nix can touch all of the things that we are working on, whether you're in a WSL2 environment, on a corporate Windows laptop, on your MacBook, trying to enjoy an Apple Silicon chip with a shared memory architecture, or if you're just on your phone and want to play with Nix inside of an Android container. We can get to a story where the developer experience on the left factors our dependencies cleanly and automatically from the beginning, such that we can move them into production with a low layer diff and have a better time, just not pretending that our CVE scanners are actually lying to us. So, not trying to throw shade. We could do better. So, thanks everyone. This is Cloud Native Nix in the context of why you should care as a containers person. And my name's Leigh. Feel free to find me and chat about it. So.
Do we have a question? I think one question we can take. Anybody? A question? Otherwise, yeah. Thanks again, Leigh. And.